Hello and welcome to quicktechie.com. Today we're going to be looking at this intriguing image that compares two different versions of Apache Spark and how they handle data using data frames. This is a great illustration of how Spark evolved to handle both batch and streaming data more efficiently. Let's dive in, shall we? 1. The title: Spark 1.3 versus Spark 2.0. This tells us we're looking at a comparison between two major releases of Apache Spark. Spark, as you know, is a powerful open-source, distributed processing system used for big data workloads. Version 1.3 was a significant release, but version 2.0 introduced some major architectural changes, particularly in how it handled streaming data. 2. Spark 1.3 Static Data Frames. Static data frames. The keyword here is static. In Spark 1.3, data frames were designed primarily for batch processing. Batch processing. Think of batch processing like doing your laundry. You collect all your dirty clothes, data, throughout the week, and then you process them all at once in a big batch on laundry day. Similarly, batch processing in Spark involves processing a large, bounded dataset that has already been collected and stored. The image. The grid image under Spark 1.3 represents a traditional data frame, a table with rows and columns, similar to a spreadsheet or a database table. It represents a fixed amount of data. 3. Spark 2.0 Continuous data frames. Continuous data frames. This is where things get interesting. Spark 2.0 introduced the concept of continuous data frames, also known as structured streaming. The key word here is continuous. Quote, streaming data. Unlike batch data, streaming data arrives continuously, like a never-ending flow of water from a faucet. Examples include data from social media feeds, stock tickers, or sensor readings from IoT devices. The image. The image under Spark 2.0 is similar to the 1.3 image, but with a crucial difference: the downward arrow. This arrow symbolizes that new data is continuously being appended to the data frame, like adding new rows to the bottom of the table in real time. How it works. In structured streaming, you essentially define your data processing logic, transformations, aggregations, etc., on a data frame, as you would in batch processing. However, Spark treats the streaming data source as an unbounded table, meaning new data is constantly being added. Spark then incrementally and continuously updates the result table as new data arrives. 4. Single API. This is a big deal. Before Spark 2.0, handling batch and streaming data in Spark required using different APIs, like DataFrame and DStream. Spark 2.0 unified these APIs under the DataFrame API, and later, the Dataset API, which is a more type-safe version of DataFrames. The benefit. This unification meant that you could write your data processing logic once, and Spark could apply it to both batch and streaming data with minimal changes. This significantly simplified development and reduced code duplication. Concepts missing in the image, but important to understand. Micro-batch processing. Spark structured streaming doesn't process each individual record as it arrives. Instead, it groups incoming data into small batches called micro-batches and processes them at small time intervals, e.g., every few seconds. Triggers. You can define how often Spark processes these microbatches using triggers. For example, you can set a trigger to process a new microbatch every 2 seconds, or after a certain amount of data has accumulated. MIDI. Event time versus processing time. In streaming, it's crucial to distinguish between event time, when the event actually occurred, and processing time, when Spark processes the event. Spark structured streaming allows you to handle event time correctly, ensuring accurate results even if data arrives late or out of order. Windowing. A common operation in streaming is to perform calculations over a sliding window of time, e.g., calculating the average temperature over the last 5 minutes. Spark structured streaming provides powerful windowing functions to handle such operations. Watermarking. To deal with late arriving data, Spark uses a mechanism called watermarking. You define a watermark that tells Spark how long to wait for late data before finalizing the results for a particular window. Fault tolerance and exactly once semantics. Structured streaming is designed to be fault tolerant. It can recover from failures and ensure that each record is processed exactly once, even in the presence of failures. By using techniques like checkpointing and write-ahead logs, which also was not included in image. Dataset API. While the image focuses on DataFrame API unification, it is worth noting that Spark 2.0 also introduced the Dataset API, which provides a more type-safe way to work with structured data in Spark. Data frames are actually a special case of datasets, dataset row, providing the flexibility of working with untyped data when needed. In essence, this image highlights a major shift in Spark's approach to data processing. By introducing structured streaming and unifying the API for batch and streaming, Spark 2.0 made it significantly easier for developers to build powerful, real-time data processing applications. It paved the way for more sophisticated stream processing use cases and simplified the development process by allowing a single codebase to handle both batch and streaming workloads. This is a foundational concept in modern big data processing, so make sure you understand it well.